Hi, this is Manu from Claymatrix Data Labs, and today we're going to discuss the part 2 of the machine learning project on IRIS Dataset. So I hope you've gone through the part 1, wherein we discussed the nuts and bolts of the IRIS Dataset, what the problem statement is, and we also discussed a bit about the framework, about how machine learning is done in Python. So today we're going to we're going to implement the machine learning project using IRIS dataset in our Python environment. So let's move to the IDE, and I generally use Spider IDE. You're most welcome to use any IDE of your choice. I somehow find it more convenient, so I stick to Spider. So like we discussed last time, the major component of this task are: we need a data set, we need to split it into test and train, and then we need to build a model or choose a model rather, then feed in the information into a way which checks the accuracy of the model, and if the model is within the acceptable accuracy limit, we accept it, else we repeat the process by choosing some other model, maybe KNN, logistic regression, random forest. So on the same lines, we will need few things to do this. So number one, we need to import some libraries. We are using the pandas library because we are going to import the data, for which we'll need the pandas library. Then we need to split the data set. So the most important library here is the sklearn, which has various subcomponents which would be used in the various legs of this program. Then we also need to import different models we will be using, or rather we will be demonstrating this exercise using logistic regression and decision tree. So we need these two models which come in with sklearn. We would also need the sklearn matrix, which actually helps us to gauge few of the parameters of the model. More precisely, the accuracy of the model is what would be used in this program using the matrix function of sklearn. And then we would use Seaborn to visualize a few of the aspects of this data. Now, before we begin, this is just a demo, because to build a real world machine learning model that you can deploy on your production, you need to take care of a lot of things. So it's not that easy. I won't say it's tough, but it needs a lot of things to take care of. So this is just a demo, and once you go and graduate to a higher level in machine learning, you will realize a lot of other things, small intricacies that have to be taken care of. So the first step, importing the data. So we would be using the read CSV function of the pandas library, and since my data is lying somewhere in this path, I'll import it and pass it as a data frame data. Right now, there are ways to directly use this data set, because it comes bundled with the Python environment that you're using. For example, if you're using Anaconda, it might come in along with the package, but to make things simpler, I'm just using it from one of the folders where it's kept in. Now, next thing would be to look into the data, right? So let me first run this. So let me run up till here, and if I run up till here, so which means we have imported the required libraries and our data frame data is available with us. So in Spider, it's pretty handy to see. If I go to my variable explorer, I can see that this data is already here, which is of the type data frame. The size is 150 by 5, which means 150 rows and 5 columns, and the column names are namely sepal length, sepal width, so on and so forth. If I click here, a double click rather, I can even have a look or a peek into the data. So this is the data which has been imported from the CSV file. Now since this data frame has the data, and if we recollect from the part 1 of this session, we discussed that this data has to be split into two parts, the test and the trained part. We'll come to that shortly, but before that, in real world scenario, you might also want to have a look into the data or a peek into the data, so for which you can use these following commands, and there are few more. So for example, the head will give you a look into the first few rows of your data set like this, which is already available because we're using Spider, so we can use the variable explorer. Info also is a handy thing which gives you slight more information about your data set, and then you can use the describe, which throws out some statistics around your data set. Now, how to infer this and what all precautions you need to take based on these information. For example, which model to select, whether you need to curate your data further or not. All this will depend upon your statistical learning and abilities. So we're not going there as of now. But yeah, this still is an important part of a machine learning model. Next, going or learning more about the data, we need to visualize the data as well. So as we've already imported the Seaborn library as SNS, so we will use the pair plot function of SNS, which what it does is it gives you a plot which looks something like this. So if I look at the plots, so I have a plot here, and it is if I kind of zoom it out for you a bit, let me do it. Yeah, so what it does is actually it plots each of the parameters against the other parameter, right? So we have sepal length against the other 4 parameters, similarly sepal width along across the other parameters, so on and so forth. Now, though we are not going into analyzing the data, because that again is a required thing, but we're just doing a demo on how machine learning models work or are made. But just to give a small insight, you can see that these different color dots represent different species, these 3 species, and the blue, orange and green are segregated here. You can see this. Over here they are less segregated, but over here the boundaries are pretty clear. Similarly, over here the boundaries are pretty clear. So if you get more into this data, you will realize that out of petal and sepal, petal gives you a better classification of the data, because over here the boundaries are pretty clear, but if you use sepal, the boundaries start merging together. So petal is a better measure or a better way to classify this data, but again, like I said, we will just demo the how machine learning model is made. Now, if you want to analyze the data further, you can even use the heat map from Seaborn library, and you can, as a matter of fact, use other plotting libraries as per your choice. So just to give you one more visualization, an idea about the visualization and how you infer it. So now this time we are using the heat map, and if I kind of do it out for you a bit, you will see that now we have a heat map, and the darker shades mean more correlation, lesser shades mean less correlation, and you'll see again that these dark spots represent when we have a petal as a feature, and when we move from only sepal to sepal correlation, it would be a less lighter shade. So which means petals are a better representation of or have a better correlation when it comes to this data set. Again, like I said, a lot of other things that you need to factor in. So coming back to our program, now since we visualize the data, and in real world this will help you to take requisite measures by developing the model. Now, if we go back to the presentation on the part 1, you will see that the dataset is composed of two parts, x and y, which are the independent and the dependent variables. So on the same lines, we need to break this dataset into this x and y subcomponents. So we'll pass each of these dataset x and y into two data frames. So let's do that. So what I'll do is I'll pass the data without the species column, which means just the 4 columns, into the variable or the dataset or a data frame rather x, and I'll pass just the species column into the data frame small y. So over here we are saying in the data frame data, which is the entire data set, drop the species column and pass it into the data frame x. So x and small y become two data sets, each representing your independent and the dependent variable. So if I again go to my variable explorer on my spider ID, you will see that my data frame now has these 4 features as we discussed last time, and the y is the target or the output data frame. So now since we have our two x and y as our two data frames which represent the dependent and the independent variable, we will split the data into the test and train. Now splitting the data into test and train is pretty standard in Python. We'd already used or imported the train test split here, so we can call this function here train test split, and we are assigning the two split data set and the underlying variables with these 4 variables. So x train is the independent variable in the train data set, x test is the independent one in the test data set, y is a dependent variable in or data set in the train data set, and y test again the dependent variable in the test data set. So once we use train test split and we pass x comma capital X comma small y, it says that split this x and y into train and test subcomponents, and then there are some parameters that you need to pass with the train test split, which you can explore further as per your requirement. So now once we run this, I'll just run this line of code, and we'll see that now we have x test, which has, you can see, 60 rows, and x train, which has 90. So 90 and 60 is 150 over here. So it has been split into 2 parts. Similarly, the y test and y train. So just to show you, this is the x test. So this would be having some number of data. These are the index coming from the original, so don't confuse it with the numbers. This record would be 60, and this x train, again, this would be your train data set, which is around 90 over here. Let me just position it so that you can easily have a look at it and also infer the data easily. Yeah, so like this, and the other one like this. So x test and x train, and then comes the y test and the y train. So just let me bring it here, and this is y test, and then the second one would be y train. So y test and y train. So I'm just doing it so that you know that once you split, how the actual things are working in the backend, and like this. So now you can see that this is the x test, y test, and x train and y train, right? So now we have these 4 data sets split across by the train test split function. Now let's go back to a PPT just to have a look. So this is now what we have, and I just showed you these 4 data sets already being captured by Python, created by Python rather, and now we need to feed this into a model, right? So which means we need to first use the train data set, pass it into a model, and then use the test to see the accuracy. So for this demonstration, we are using two models. One is logistic regression, and the other one is decision tree. We already used or rather imported this over here. So the standard way to create a model is you just say give a name to the model. It could be anything, XYZ. So I'm naming it as just model, and model is equal to, and this is how you define the logistic regression model. So once we define the model, we need to also fit the model, right? So what we do is we are saying that this model, this variable model, means this is a logistic regression model, and then we use this model and fit it with our X-train and Y-train data set. So as simple as that. So once you do this, your model is created, and after this model is created, you can check how this model is behaving by using the test data. So I'm passing the X test here, and I use the predict function. So I say model.predict X test, and this will give me the predicted values or the Y values which are predicted. So I'm passing them as Y predict. Now and I'm printing it over here. So I'm printing over here the accuracy of the model. So for that I'll use the metrics. If you remember, we imported metrics from sklearn. So I'm using the function accuracy score, and then I say Y test and Y predict, which means see how your values are in Y test and see how your prediction has fared. So if you remember, in our PPT over here, so we discussed that how our model predictions fare as compared to our data set values, and this will give the test of the accuracy. So coming back here, so again to summarize, the model 1, it's a logistic regression. We say model is equal to logistic regression. This is the standard way to define it. And then I say model.fit, and I fit the X-train and Y-train data set, and then we use the model after fitting to predict values using the X test and pass the output into Y predict, and then we test the accuracy over here. And for accuracy, we need to check how the model is behaving by Y predict, and how our data is actually there in the data set. So whatever the discrepancy is there is captured in the accuracy score. So let's run this. So we had already run up till that split function, and now if I run up till here, so you will see the accuracy is 0.983 with this logistic regression model. Now let's repeat the step with the other model, which is a decision tree. Now again, you have to define a model the way you did here. So in this case, we're going to use decision tree classifier. This is the standard way to define it. And then again, you will do a model fit, your X train, Y train, X test and Y test all remaining the same. Again, you feed the X train and Y train data set and try to fit into the model, and then you again do the prediction using the X test data, and then finally print the accuracy. So this time if you run the model, so you see the accuracy is 0.95. So this way, whichever model is giving you the better accuracy, you pick up that model, and you can even further try other models like KNN, or there are few other ways to do it. and then you can arrive at the model that gives you the best results. Having said that, there are a lot of other things that you need to take care of. For example, when we are splitting the data set here, you might need to use a k-folding wherein we um, use different levels of split. For example, you can split at 80-20 ratio, 60-40, 50-50. So which one is the best, you don't know, and at what level you split. So all those things have to be taken care of, and a specific split might give you the best result. So yeah, that's one factor. And then you need to carry out a lot of statistical tests, and you need to see the accuracy of your data. In real world, the data would not be as clean or as clear. So all those things have to be taken care of. Just putting it up as a disclaimer so that you just don't think that this is all it is required in creating a machine learning model. This was more of a demo so that people who are just trying to get going into machine learning, building their first machine learning model, they know which spots to hit and what all to look at. So I hope you found this session on machine learning interesting. If you like our videos, do subscribe to our channel and follow us on our social media. So that was the culmination of the machine learning model using IRIS Dataset by Climatex Data Labs. Stay tuned for more, and we'll connect soon. Thanks.